Oh, hello again. This is structural analysis made fun and easy. So this is part 6. This is looking at where the resultant reaction is for the overturning moment for the anticlockwise moment is about x. So that is basically it's not actually RV as well, because it not necessarily RV. In the textbook it says RV, but it's not. I'm going to have to do another video because it's not quite right. I call it resultant reaction, vertical resultant reaction times the lever arm equals m. So we got m, so the lever arm for m equal the lever arm is m over r. So the lever arm is 527.3 from up here divided by 282.3. That's RV, but it's only because I do another video, but vertical equilibrium RV equals RR. But I do that in another one. It's not quite right. It's not shown properly. So the lever arm is 1.86 meters. RR. So if you had a force of 282.3, which it must be because of vertical equilibrium, then that must act at 1.86 from x. Therefore, RR. So just to show what I've done, RR times 1.86 equals 527.3. So basically, the resultant force is at 1.86. So sorry, I need to do the diagram again, but here's the diagram of the base. What you got basically is the safe zone. So it's got to be, the reaction's got to be within the middle third, otherwise it's unstable. So if it's that's not, and sorry, that is not quite true. So because it's an anti-clockwise moment, therefore if the reaction was on the right side of the middle third, then it would still be okay, because the moment's so small it doesn't do anything. So if it's on the left of the middle third, then with an anti-clockwise moment, then it's unstable. I guess it would be the other way around. If it was clockwise moment and it was on the right of the middle third, then it would be unstable as well. But on this one, so that this little bit I shaded in the middle, that's the safe zone. So the reaction has to be within that safe zone. There's the centre line. The base is 3 meters wide, remember? So this is the base, that's the stem. So the distance to the centre line is 1.5 because it's 3 over 2. So if you divided the base into 3, you've got three sections of 1 meter. So if the resultant is within the middle third, then it's stable. So so there's a zone of 0.5 meters on either side of the centre line. On the left of the centre line you've got 0.5, and on the right of the centre line you've got 0.5. So the distance to the centre line is 0.5, and then you're allowed to have 0.5 eccentricity, and then it would still be okay. So there's 3 sections of 3, yeah. So it's so the eccentricity in this case is from the centre line. He means the eccentricity from the centre line is 1.86 minus half the base width, which is minus 1.5, 0.36 meters. So it's okay, because as above I said, you're allowed to have up to 500 millimeters eccentricity, and you've got 360, so it's alright. So the resultant reaction up. So basically, because I do another video, but so the next calculation is to look at the stresses using the centre line, not the heel point. But basically, because you had there was 1, 2, 3, 4 vertical reactions, you'd actually have a centroid of the vertical reaction, which isn't exactly in the same place, because of so this, it's not quite right, this what they've done. And the result, you could say that RR is the reaction under the base due to the overturning moment, but that also must be by vertical equilibrium. That's got to be the same as the RV value. So the result is within the middle third. So let's just say, in other words, what moment would make it unstable? That would happen if the eccentricity was 0.5 or more. Then then it would be unstable. So the lever arm would have to be 2 meters or more. So that would be 1.5 plus 0.5. Then M over RV equals greater than 2. M would be equal to or greater than 2 times 282.3. So 564.4. So if M was greater than 564.4, then it would be unstable in this case. That's where you've got the weight of the soil, the concrete, holding it down. So thanks. This is end of part 6 now. So please stay tuned for part 7. This is structural analysis made fun and easy. RJ Nash, 10th of July. And please like and subscribe to the channel and stay tuned for just the conclusion of this problem, where I'll just finally find the bearing pressures under the base.